My name is Garikai Chinakwe, and we are going to look at probability. Probability is one of the easiest sections in paper one. It is as in paper one, and it doesn't carry lots of marks, but you are supposed to get everything in probability. So let us just look at the simplest question that they ask, the one that you're supposed to get marks. For example, you may be given that a fair die is thrown and a coin is tossed. This is probability. All right. They say a fair die is thrown and a coin is tossed, and the coin is tossed. And the question is that determine the probability of obtaining a tail and a 3, and the coin is tossed simultaneously. Determine the probability of obtaining a tail and a 3. A tail and a 3. Okay. All right. Whenever here, I'm just gonna underline this word "and." Whenever there are two events taking place, and now they want you to determine the probability of obtaining a tail, and we know that first of all you must know the probability of obtaining a tail. Probability of obtaining a tail, this is how you write it. We know that there are two outcomes. It's either a head or a tail. So in other words, the probability of obtaining a tail, it is half, because there are two of them. And for you to obtain the probability of getting a tail, it must be a half. Then the probability for obtaining a 3 on a die, and we know that the number of possible outcomes when after throwing a die, we know that it is 6. So obtaining a 3, it is 1/3. Therefore, the probability of obtaining a tail and a 3, it is equal to half multiply. You're supposed to multiply these two events. Multiply by 1/3. So you're going to get 1/6. Okay. So in other words, if they say and, you're supposed to multiply. Okay, then let us move on to the next one. A fair die is thrown simultaneously. Two fair dice, okay? Two fair dice are thrown simultaneously. So this is the first one. Are thrown simultaneously. For 3 times. Okay? 3 times. The question is, what is the probability of obtaining at least 1 3? What is the probability of obtaining at least a 3, or at least 1 3? Okay, so this is the question. All right, what you know is that the probability of obtaining a 3 on one die. Probability of obtaining a 3, we know that it is 1 over 6. Okay, but now we are throwing these dice. How many times we are throwing them? 3 times, and there are 2 of them. So therefore, probability of getting not a 3, obtaining not a 3, we know that it is 5 over 6, isn't it? So if you say at least, it means you're supposed to subtract 1 minus 5 over 3 for one die. But now there are 6 of them. So therefore, probability of getting at least a 3, we're just going to say 1 minus probability of obtaining not a 3, we know that it's 5 over 6. But for how many times? There are 2 of them, so in other words, there are 2 dice, but we are throwing them how many times? Times 3. So which gives us 1 minus 5 over 6 to the power of 3. 1 minus 5, is 1 minus 5 divided by 6, all to the power of 0.65, 0.067. That is the probability. All right, we're still on probability, and this time I need to introduce you to Venn diagram, drawing of Venn diagram. All right, first of all, let me just write Venn diagram. Venn diagram. Now let me just try to draw Venn diagram so that maybe you have a background knowledge on Venn diagrams. All right, first of all, I'm going to draw this. Let's say this is event A, and then this is event B. Okay. Event A and event B. All right, where I am shading here, this one we call it A intersection B. This is A intersection B. All right. Then A intersection B, when you're working out, it is like, oh, okay, let me just, if this is A intersection B, or sometimes we call it, or we say A and B. A and B. This section is A and B. Now, if you got something like this, let's say this is event A, let's say this is event B. So this one, I'm shading everything there. I'm shading everything. This event is A union B, or we call it A or B. That's the event. All right, and then I'm going to write this again. Let's say this is event A, and then on event A, I'm going to shade outside A. Let's say this is the universal set. Okay, I'm going to shade outside A. Where I've shaded outside A, we call it A complement. Or in other words, it is not A. Not A. A complement is not A. All right. Then, on this case, let me just repeat this. A intersection B. That's where A and B, that's where that region where we find A, where we find B. We call it A intersection B. Sometimes we call it A and B. Then A union B, we call it A or B. Then outside A, we call it A complement. Okay, but sometimes you'll be given something like this as well. They'll give you 3 events. They'll give you 3 events. And then those 3 events, you'll be given something like this. You'll be given something like this. And then this is event A, B, and C. This is event A, this is event B, this is event C. Okay, let's start with this one. Where we find A, we find B, we find C. This is A, intersection B, intersection C. In other words, we can call it A or B or C. Okay. Then if you got something like this, you got something like this. This is A, this is B, and this is C. This part is A or C. That's the part. It's A or C. Or it's A intersection C. Okay. But let me just use the same diagram. This is A or C. A or C. Let me use the same diagram again. And then I'm shading this part. So this part is A or B. So it's A intersection B. A intersection B. This is A or B. A intersection B. Same story again. Then we've got this. Again. Let me use. I'm going to use this diagram on top. All right. You see this diagram? I want to check everything on A. This is A only, A only, or this is A only. Okay. Then, we've shaded A only. This includes A only. Then I'm going to erase this and show you another one. You see this one, and this one, and this one. Shading A and B then. I'm shading A or B. This is A, and then this is B. So in other words, this is A union B. Sometimes it is called A or B. So there's a difference between or. Or it includes everything. And it's only that those sections where the two graphs, where the two events, where they intersect. So this is A or B. Okay. All right. And then sometimes you'll be given something like this. Sometimes you'll be given something like this. All right. I told you that if you shade this one, this is A. This is just A. And if it is like this, and this is A, and then this is B, and then this is C. So this one is A only. So it's the shaded part, it's only including A only. It doesn't include other parts. It's A only. Then this is A. So there's a difference between A and A only. A only is that part where we only find elements in A. They are only found in A, not in other parts. But this one is A. So there's a difference between A and A only. Okay, you must take note of that. Just like this B as well. Just like this B. Alright, let's say this is B. This is A. This is B. So this is B only. Only that section of where is B only. This is B only. So you must be careful. This is A. This is B only. This is A. This is A only. Where elements they are found in A, they are not found in B. They are not found in C. They are only found in A. Then this one is A only. Everything that is in A is A. Okay, you must also take note of that. And then I'm going to erase everything. And I'm going to give you an example whereby it involves Venn diagrams. Okay, for example, in a survey to find out which TV station has wider viewership during prime time. All right, in a survey to find out which TV station is a wider viewership, is a wider during prime time. Hundred and 50 viewers were questioned. 150 viewers were questioned on which TV station they preferred, on which TV station they preferred. Most amongst TV politics, TV politics, TV news, and World News TV, and World News TV. The responses are as follows. The responses were as follows. The responses were as follows. The first one is 40 preferred TV politics. 40 preferred TV politics. And then the other one, 60 preferred 60 preferred TV news, and 50 preferred World TV. 50 preferred World News TV. Okay. And then 20 preferred both TV politics and TV news. 20 preferred both TV news, TV politics, and TV news, and TV news. Okay, and then 32 preferred both TV news. 32 preferred both TV news and World TV news. And 50 preferred World TV news, World TV news, World News TV, and TV politics, and TV politics. And the other one, 30 preferred all the three TVs. 30 preferred all the three TVs. Okay. Then they say the first question is that draw, this is question A, draw a Venn diagram for the above information. Draw a Venn diagram for the above information. Okay, that's what you're going to draw. All right, if you're drawing the Venn diagram, you can see that there are three events there. There are three TV stations. So we are going to draw the first Venn diagram there. This diagram, including this one, and then the third one here. So the first one is for TV politics. So it's TV politics. And then the second one is for the first one is TV news. TV news. And then the last one is for world news TV. All right, we are continuing with our question. Let me just read this. What is the probability that a viewer chosen at random prefers world news TV only? World news TV only. You go on to world news. You can see the world news. This is where we find the world news. And one world news TV only. It is this one, which is only. It is this part. So it's 6/226. So in other words, how do you present your work? You're supposed to write it like, all right. Probability of world news only. We know that it is 60/226. Then you're supposed to simplify that. And we're supposed to simplify that. Which is 30/113. 30/113. So that's the probability. Okay, the next question is that it says that what is the probability that the viewer chosen randomly from, okay, the other question is that what is the probability that a viewer chosen randomly from the sample prefers none of the three TV stations? Okay, let's leave this one because it's a different question. What is the probability that a viewer chosen randomly, let me just write down the question here. What is the probability that the viewer chosen randomly from the sample prefers? What is the probability that a viewer chosen at random prefers TV politics and TV news? TV politics or TV news? TV politics. All right, let me call this one number 1. TV politics or TV news. Then number 2, TV politics. This is TV politics and TV news. So these are two different questions. The other one is with and, the other one is with or. So let's start with or. TV politics or, which is part 1, which is probability of TV politics or TV news, which is equal to TV politics or news. If they say or, it means you are including everything. In other words, you are supposed to say 40 plus 7 plus 13 plus 37 plus 60 plus 19 over 226, which is going to be, I'm going to use a calculator quickly, which is going to be 226, which is going to be 176 over 226, 176 over 226, which gives us which gives us 88 over 113. So that will be for all. Now let us move on to the next one, which says that, let me just use this one now, which says that, which says TV politics and TV news. TV politics and TV news. Now we look at and it only includes 13 TV politics and so it's 7 and 13, so it's 7 plus 13 over 226, which gives us 20 over 226, which gives us 10 over 113. So you must be careful with and or. And or, those are two different ones. If they say and, it's only that section whereby it's intersecting. If they say or, it's everything that is in TV politics and everything that is in TV news. You add it. Okay.